Hello everyone, welcome to this video of basic electronics module. Now from today onwards we are going to explain and learn the basics of electronics. So here our first lecture goes. So today in this lecture we are going to introduce you with the basic electronics, that what is basic electronics and what things you will have to keep in mind. So this is nothing but an introduction lecture for you to get the basic knowledge of basic electronics. As you can see on my display, these are the devices which you can refer to as basic electronics. So these are the devices you can see around you, just such as a laptop, printer, mobile phone, keypad, tablets, everything. These are basic electronics. So here the flow of our today's session is going is I have divided this into four categories. So this is our table of contents, which is first we'll see introduction. In this section, you'll learn what is basic electronics, its application and advantages and disadvantages, and then we'll move forward with semiconductors. So in this section, you'll learn about the different materials, like which kind of materials are there in the market, and basically we will focus on semiconductors. So which are the semiconductors and their properties. Then we'll move forward with the voltage. And in the end, we'll see what is current and basics of voltage and current. So let's just focus on our first introduction slide. So this is the introduction. So we'll see what is electronics. So electronics is about manipulating electricity to accomplish a particular task and is very much a hands-on endeavor. So electronics is the devices you can see around you. Nowadays, there are so many basic electronics devices you can see around you. For example, a laptop, a phone you're using whole day, a printer. These are the devices which make our lives simple, easy, and these help so much in our day-to-day life. So the topics in this slide are going to introduction to basic electronics, advantages, disadvantages, their examples, and where we can apply them, so the basic applications. So what is basic electronics? The term electronics is derived from the word electrons. Electronics is a branch of physics that deals with the theory and use of devices in which the electrons travel through vacuum, gas, or semiconductor medium, in whichever medium. But the basic thing is electrons travel through something in these devices. The motion of electrons take place under the influence of applied electric and magnetic field. So for that, there should be something, as you can say, electric or magnetic field. So what is basic electronics is, so the term basic electronics, or you can say electronics, is derived from electrons. So what are electrons, and its flow and everything is included in electronics. So electronics is a branch of physics that deals with the theory and use of devices in which electrons travel through, you can say, vacuum or glass or semiconductor medium. So in whichever medium electron travels, and the study and the physics of that theory deals in electronics. So the motion of electrons take place under the influence of applied electric and or magnetic field. So whenever there is electric or magnetic field applied, there will be a flow of electrons. Now whenever you are making a circuit, you'll need three basic elements, and these three basic elements are a voltage source, a conductive path, and a load. Now I'll see what I will tell you what is voltage source. A voltage source would require to cause a current to flow. So these are nothing but to provide you with a current. Then there is a conductive path, means a path through which your current will flow. And a load is nothing but the thing which you want to eliminate or turn on. So through a voltage source you'll provide a current, and through current conducting path that current will flow to the device which you want to turn on. For example, you want to turn on LED, so LED will be your load. The jumper wires or cable you are connecting, that would be your conducting path, and a battery, for example, you are using to provide current or voltage, is your voltage source. Some of the most commonly used electronic components are resistors, capacitors, inductors, diode, LED, transistor, and some electromechanical components are relays, switches, ICs, and collectors. Now, after seeing the basic definition of basic electronics, now we can divide their advantages and disadvantages in a list. So, as we mentioned, the basic electronics devices, you can see the one advantage as easy access to information. For example, through using your laptop or phone, you can easily get any information, or you can see the news on television. So, easy access to information. Second is encourages innovation and creativity. As we have seen the uh, keypad phones, and now we are using some of the TVs and laptop as a touchscreen module. So this is nothing but innovation and creativity in this technical field. So it encourages innovation and creativity. Now improved communication. Using mobile phones and laptops, you can connect with anyone anywhere. Like you have relatives or friend miles away from you, you can just call them in just one touch, or you can see them in video calls. Then convenience of traveling. So using buses and the trains, you can easily travel anywhere. And now the advancement of technology has reached to airplanes, so you can travel through beyond the thousands of miles using airplanes. Improved housing and lifestyles. So basic electronics are some examples of electronic appliances are microwave, oven, your refrigerator, and washing machine. These are the devices which have made your life easy and fast. Improvement in entertainment. Using your TV and phone, you can watch movies and different kind of entertainment. Then efficiency and productivity. So using laptops, phone, and some equipments, you can efficiently work and your productivity has increased. Convenience in education. For example, using laptops, projectors, and phones, you can easily operate YouTube and any other educational site, and you can read, write, and learn anywhere, anytime. Now, after seeing the advantages, let's see the disadvantages of this same module. So increased loneliness. As the devices around us has increased, the human are increased in captivity. Like they are feeling lonely as they are surrounded with so many gadgets and devices. Then job loss. The particular work men were doing now taking place by these computers, laptops, and these smart devices. So there is a little bit risk of job loss. Then competency, then world destruction weapons. Using the advanced technologies, the people and nations are making major weapons which can destroy a whole country in just a few seconds. So these are some of the threats or disadvantages. Then after we have Now, after seeing advantages and disadvantages, let's discuss their application or area of their application. Now, as I mentioned earlier, there are so many devices or basic electronics devices. So their main purpose are we are using them in our day-to-day life are, for example, mobile phones, computers and laptops, tablets or iPads, electronic or you can say smart watches, Bluetooth speakers, digital camera, television or TV, music player, game consoles, electric toys, electronic bell, USB lights, and amplifiers. So these are the devices which uses small or bigger part of semiconductors, conductors, and different materials which are in the short are basic electronics devices. Now, after this, we'll see the different materials and semiconductors. So, there are basically three types of any material, or you can say you can divide this different types of material in three categories, which are conductors, insulators, and semiconductors. Starting from conductors, So basically, conductors are the material or are the things which which allows current to flow through them. So these are the materials that permits flow of electrons are called conductors. For example, gold, silver, and copper. And copper is the conductor which is widely used in making of cables and jumper wires. Now, then after there is insulators. As the name suggests, insulator are the materials which blocks or which denies the flow or which resists the flow of electrons. So the materials that block flow of electrons are called insulator, and some of the examples are rubber, glass, Teflon, mica, etc. So these are the materials through which you can make insulators. For example, your jumper wire or cable has the conductor in it, and after conductor they are wrapped with the insulators, means the rubber, to prevent you from shock hazards. Then after there is a material which are widely used nowadays are semiconductors. So semiconductors are nothing, as its name suggests, semiconductors means conductors but semi, means it has some property of conductors and some properties of insulator. They fall between conductors and insulators. Semiconductors are the material whose conductivity falls between conductors and insulators. And some examples are silicon and germanium. So silicons are widely used in making chips nowadays. So basic difference between insulator, semiconductor and conductors are the level of their conductivity, means the rate of current flow. In conductors, the rate of current flow is highest, while in insulator, the rate of current flow is the lowest. While the semiconductors are uh, allow or permit the moderate flow of current, means not too much high, not too much low, as an insulator. So in image you can see insulators are the gloves made from rubbers, which are you can see. Then semiconductors which are used to make resistors and different kinds of chips which are used in phones, TVs, and laptops. And then after conductors which are used to make different types of cables and jumper wires. Now semiconductors, as you can see in the image, the semiconductor devices are op-amp, ICs, transistors, diodes, capacitors, and resistors. The semiconductor nowadays used in widely in each and every devices. So the global semiconductor market was 527.88 billion in 2021 and estimated of 1380.79 billion in 2029. So these are the materials which are widely used, and different materials have different properties. So different semiconductor materials are used to make the different kind of devices according to their properties. For example, if a semiconductor device has a higher property of light emission, that then they are used to make light emitting diode. So in certain semiconductors, excited electrons can relax by emitting light instead of producing heat. So as you can see, whenever there is a current flow through any material, there will be a production of some percentage of heat. But the devices or the materials in which this production of heat is less or approximately to zero, and instead of that production of heat, the emission of light is bigger. So these the kind of materials are used to make LEDs, which are light emitting diodes. Then after, high thermal conductivity materials. These are the thermal materials which are used to make electronic devices which are used in thermal management. Then after, thermal energy conversion. Semiconductors have large thermoelectric power factor, making them useful in thermoelectric generators. So these are the devices or these are the materials which are used to make thermoelectric generator as well as high thermoelectric figures of merit, making them useful in thermoelectric coolers. So these are the devices which are used in thermoelectric generators and thermoelectric coolers. Now after seeing the different properties of them, now we will see the application, real life application of the semiconductors. like where you can see this semiconductor materials. So in personal computers and television, different types of chips, resistors are used, which are made up of semiconductors. Then there is a application in industrial and manufacturing usage. Means in industry and manufacturing part, there are devices like resistors and different kind of capacitors and inductors are used in industrial level. Then in bank ATMs, there is a chip. There is always a chip in your ATM card which is made up of semiconductor. Then in automobile, means in vehicles. In vehicles, there are different type of semiconductors are used. Making of electronic gadgets. Gadgets like your smartphone, gaming consoles, these are electronic gadgets, or you can say microwaves or refrigerators. These are the electronics in which the semiconductor materials are used. In advanced medical devices. In medical devices, there are semiconductor chips which are used. Then, as seen in this image, the widespread applications are in communication products, means you're in smartphone, telephone, and tablets. Then, in infrastructure and industrial equipments, means in trains or your vehicles, your personal computers, or in camera, there are some percentage of semiconductor materials used. In home electronics, means your microwave, your washing machine, your air conditioner, digital camera, TV, game console, and solar all has some kind of semiconductor materials in them. Now moving forward to our third topic, which is voltage. In this section, you'll learn about basic building block of electronic voltage, its SI unit and formula. So let's move forward to what is voltage. So voltage is nothing but it is a charge between 2 points in electrostatic field. Voltage is also referred to as electric potential difference. Means electric potential difference between 2 points is nothing but voltage. It is the difference in the electric potential between 2 points. It is the work done in moving charge from one pole to another through a wire. Means between a wire there is a one end and there is a second end, and in between these 2 points there is the work done which is referred to as voltage. The mathematical representation is as the seen below is voltage is equals to IR. So here V refers to voltage in volts, I is nothing but current in ampere, and R is resistor in ohms. So after seeing voltage, now which are the voltage sources? So as you can see in image, these are the voltage sources. For example, a cell, a single cell, or a battery, or you can say the windmills and the dam. These are the voltage sources. A voltage source is a two terminal device which can maintain fixed voltage. So, for example, a cell. A cell has two terminals and in between they maintain a fixed voltage. For example, 3.3 volt, or the cells are of 1.2 volts. So, the specific voltages are maintained between two terminals, plus and minus. An ideal voltage source can maintain fixed voltage independent of load resistance or the output current. Means it never changes or it never varies irrespective of connected load or the output current. However, a real world voltage source cannot supply unlimited current. So the SI unit of this voltage is volts and denoted by capital V. Now you can see in image, this is three cell battery. This is nothing but a series combination of three individual cells. So this is a three cell battery. Here black wire, as you can see in the image, is providing ground, means 0 volt. Then after there is a white wire which provides you with 4 volts. Then after a red wire which is 8 volt, and the last and the only wire brown which provides you with 12 volts. So these are used to provide voltage in a circuit. Now then after our last and final topic of this module is current. In this section, you'll learn the basic building blocks of current, its formula, and SI unit. So, what is current? Electric current is the rate of flow of electrons in a conductor. So, in any conductor, the rate of flow of electrons is described as a current. When the potential difference is applied across a wire, then loosely attached free electrons will start moving towards the positive terminal of cell. So there are two terminals in through which current goes is positive, and through which it start flowing is generally referred to as negative. This continuous flow of electrons make the existence of electric current. The mathematical representation of current is I is equals to V divided by R. So as we discussed, the formula for voltage is equals to I into R. So from that very equation you can find the equation for current as well. So I is equals to nothing but the voltage divided by the resistance. So the SI unit for this current is ampere, and it is denoted by A, capital A, while the current is denoted by capital I. So from the previous equation, I is equals to V by R, you can derive the formula for 1 ampere current. So whenever there is a 1 ampere current, there would be a 1 coulomb of the voltage divided divided by per second. So I average is equals to delta Q by delta T, means 1 ampere current is equals to the 1 coulomb divided by 1 second. So there are two types of current basically. First is alternating current and second is direct current. So as the name suggests, alternating current means a current which value varies or alters. Alter means it will have some percentage of positive and some percentage of negative value. So alternating voltage's magnitude changes with time. So here the magnitude of current changes continuously and the direction of current changes periodically. A sine curve or cosine curve represent the current as seen in the image. Alternating current is generally used to power a power application because it can be transformed from a higher voltage to lower voltage. So, as you can understand from its definition, it has a positive value, then it reaches to zero, and then after it goes in negative. So alternating current has three magnitudes, means positive, negative and zero. At a particular time it reaches to zero, then it falls, then it goes to the peak of negative, then again it rises, reaches to zero, and then again it starts increasing in positive and reaches to its maximum, and then the cycle goes on. So the advantages you can say of this kind of current is, for example, you whenever there is a shock, whenever you meet with a shock, you can you there are chances you can save a person's life. When there is a zero current, the chances of the particular person of saving increases, while second type is direct current. Direct current, the name suggests that this is the current which magnitudes never varies. Means here the magnitude of the current remains constant and the current flows in only one direction. So the magnitude of current and the direction of current never changes in direct current. So the application is most of household appliances and consumer electronics, means your light bulb, your charger, your mobile phones and laptops, which requires the low voltage and low current. That devices are operated on direct current, while the current which are coming to our house from DP are alternating current. So thank you so much. This was our first lecture.